This is Srikanth, Assistant Professor of EEE Department. In this session, I am going to discuss about the Thevenin's theorem. Here, in the module 2, we are having the network theorems. In that, we are having 5 theorems. One is superposition theorem, Thevenin's theorem, Norton's theorem, maximum power transfer theorem, and reciprocity theorem. In this, first we are going with the Thevenin's theorem. And why we are going with the theorems? That is, here theorems is a easy method to solve the different circuit, and in order to get the different parameters, we need the different techniques to calculate the different parameters. So these theorems will help us to calculate the different parameters in the given circuit, which is having more number of sources and resistances connected in the circuit. Now first let us go with the Thevenin's theorem. The Thevenin's theorem, the theorem which is given by the Thevenin, that's why it is given as Thevenin's theorem. Here the Thevenin's theorem states that in any linear electrical network consisting of number of voltage sources, current sources and resistances can be replaced with a single voltage source in series with the resistance. So whatever the circuit which is having a linear elements, and those elements which are connected together with a different number of sources, whatever the circuit between the two terminals can be replaced with a single voltage source in series with the resistance, where the value of voltage source is the open circuit voltage across the two terminals, where the value of voltage is the open circuit voltage across the two terminals of the given circuit, and the value of resistance is equal to the open circuit equivalent resistance between the two terminals by making all the active sources to 0. That means voltage source will be replaced with short circuit and current source will be replaced with open circuit, because voltage will be 0 in short circuit, current will be 0 in open circuit. That's why we are replacing the voltage source with short circuit and current source with open circuit. So this is what the Thevenin's theorem, that is, whatever the circuit which is having n number of sources and n number of current sources, n number of voltage sources, can be replaced with a single voltage source in series with the resistance, where voltage value is open circuit voltage across the two terminals and resistance value is the equivalent resistance between the two terminals by replacing the sources with 0, where voltage source is replaced with short circuit and current source replaced with open circuit. Here, this is the way we can have the circuit, equivalent circuit of Thevenin's theorem, which is having, here are the resistances, 5 resistances are connected, and here this is the equivalent circuit of Thevenin's theorem, which is having 5 resistors and 3 sources, 2 current sources and 1 voltage source, that can be replaced with a single voltage source in series with the resistance, so that we can simplify the circuit. We can simplify the circuit between the two terminals, so that is easy to calculate. Whenever we want to calculate by keeping one impedance or one resistance between these two terminals, if we want to calculate the current flowing through that particular load or any resistance, we can easily calculate the current flowing through the terminals. The steps to apply Thevenin's theorem. First thing, whatever the circuit which is given, first we need to identify what are the terminals we need to consider for calculating the Thevenin equivalent. So for that, we need to remove the load resistance. Wherever it is asked to calculate the current flowing through the load resistance, then that resistance, the terminals we need to remove. That is nothing but we need to remove the load resistance. And then after removing the load resistance, we need to calculate the RTH, that is Thevenin resistance between the two terminals by making the voltage sources to 0 and current sources to 0. That is nothing but voltage source replaced with short circuit and current source replaced with open circuit. And then after, in step 3, we are going to calculate the Thevenin voltage across the open circuited terminals without changing any other terminal, only whatever the load resistance which we have removed between those two terminals, we need to calculate the open circuit voltage, that is known as Thevenin voltage. When we got the Thevenin voltage and Thevenin resistance, we need to replace the complete circuit with a Thevenin voltage in series with the resistance between the two terminals A and B. And in order to calculate current flowing through the load, we need to connect the load resistance. Whatever the load resistance which we have removed in our step 1, that load resistance we have to add, and then we have to calculate the load current. We have to calculate the load current. This is the resistance which we have added in this step, and the same load resistance which we have removed in the first step. And now IL is equals to, we can directly write it as only a voltage which is applied, VTH is applied between RTH and RL, and these two are connected in series. So we can take it as IL is equals to VTH by RTH plus RL. VTH by RTH plus RL. Now we will go with the example, that is, find the current flowing through 40 ohms using Thevenin's theorem. Here, this is the circuit which is given with two voltage sources, that is 10 volts and 20 volts. This is the circuit which is given with two voltage sources. One is with 10 volts, one is with 20 volts. And these two sources are connected to 10 ohms, 20 ohms and 40 ohms. Three resistors are connected, and now we need to calculate the Thevenin equivalent between this A and B terminals. So we need to calculate what is the current flowing through 40 ohms by using Thevenin's theorem. So we need to calculate the current flowing through 40 ohms. So we have to remove the terminals. We need to remove the 40 ohm resistance. That is our first step in the Thevenin's theorem. So after removing the circuit load resistance, our circuit will become like this. So here, this is the open circuited terminals A and B. When it is open circuited, these two 10 ohms and 20 ohms are connected in series, and all the elements are connected in series because there is no other path for current flow, because only a single path for the current flow. and this current flows in this particular direction, that is in the anti-clockwise direction. So here in the anti-clockwise direction, if we take I is equals to, here we are having 20 volt source, here we are having 10 volt source. So 20 minus 10 is the resultant voltage between the two resistors which are connected in series. So 20 minus 10, 20 minus 10 by 10 plus 20, 20 minus 10 by 10 plus 20, that is equals to 0.33 amperes. So this current will flow in the anti-clockwise direction. This current will flow in the anti-clockwise direction. And now we need to calculate what is the voltage between A and B terminals. So whenever we want to calculate the voltage between A and B terminals, either you can calculate the voltage between 10 and between this 10 volts and 10 ohms, or we can calculate by considering this 20 volts and 20 ohms, because we are having two parallel paths after the open circuit. Whatever the parallel path you consider, you will get the same value. So here, whenever here the current is flowing in this particular direction, so VAB, this is positive and this is negative, we are considering. VAB, if we take, it is nothing but 20 minus voltage drop across 20 ohms. 20 minus voltage drop across 20 ohms. Here 20 minus voltage drop across 20 ohms is equals to VAB is equals to VTH is equals to 20 minus voltage drop across 20 ohms, that is equals to 20 minus 0.33 into 20, which is equals to 13.33 volts. 13.33 volts. This is one way of calculating the Thevenin voltage. And another way, by considering these two sources, if we write the KVL in the first loop, here minus VAB plus 10 into I plus 10 is equals to 0, where VAB is equals to 10 plus 10 into I is 10 into 0.33, that is 3.33, which is equals to 13.33 volts. So we got the same voltage in both cases because these two are parallel branches. As we know, the parallel branches are going to have the same voltage. Now we are going to calculate what is the Thevenin resistance. Here, in order to calculate Thevenin resistance, we need to remove the load resistance and we need to make the sources to non-operative. Sources to non-operative is nothing but the voltage sources are replaced with short circuit and current sources replaced with open circuit. In this, we are having only two voltage sources. So we are replacing the voltage sources with short circuit. Both 10 volts and 20 volt source is replaced with the short circuit. Here this is replaced with short circuit and here it is replaced with the short circuit. And here we need to calculate what is the equivalent resistance between AB terminals. Here if you see between these two terminals, here if you give the current is dividing. When the current divides, we can say that they may be in parallel and we need to check the final current will be same or not. We need to check the final current, whatever the current which is leaving, which is entering the B terminal. So we can say that Both 10 ohms and 20 ohms are connected in parallel. So RAB is equals to RTH, that is Thevenin resistance, which is equals to, when the resistors are connected in parallel, the equivalent resistance will be equals to R1 R2 by R1 plus R2. Here R1 value is 10 ohms, R2 value is 20 ohms. So RAB is equals to 10 into 20 by 10 plus 20, that is equals to 6.67 ohms. This is the way we have to calculate the Thevenin resistance. And then we need to calculate what is our final output which is required is we need to calculate what is the current flowing through 40 ohm resistance. So whatever the removed load resistance, we have to add to the Thevenin circuit. We have to add to the Thevenin's circuit. So here this is the Thevenin voltage 13.33, and here we got it as the equivalent resistance which has 6.67 ohms, and here the resistance which is the load resistance is of 40 ohms. Now we need to calculate what is the load current or current flowing through 40 ohms. Current flowing through 40 ohms is equals to VTH by RTH plus RL. Here VTH is 13.33 divided by 6.67 plus 40, which is equals to 0.286 amperes. 0.286 amperes. So this is the way we have to calculate the current flowing through the 40 ohm resistance in the given circuit. Now we need to go with the another example. Here we need to calculate the current flowing through 3 ohm resistance using Thevenin's theorem. Using Thevenin's theorem. Here we are having only a single source and 4 resistors are connected, and we are considering that 3 ohm resistance as the load resistance. So now we need to, what is our first step? We need to remove the load resistance. Then after we have to calculate VTH and RTH. After calculating VTH and RTH, again we have to add the load resistance. So first let us go with the removal of 3 ohm resistance. Now in order to calculate the RTH, we are going to remove the 3 ohm resistance. Here this load resistance is removed and voltage source is replaced with the short circuit. Voltage source is replaced with the short circuit. When you see between these two terminals, this 4 ohms and 5 ohms are connected in parallel. 4 ohms and 5 ohms are connected in parallel, and the parallel equivalent resistance R equivalent is equals to 4 into 5 by 4 plus 5. R equivalent is equals to 4 into 5 by 4 plus 5, that is equals to 20 by 9. That will gives the value as 2.22 ohms. Now I am replacing this parallel branch, this parallel two resistances with a single resistance, that is 2.22 ohms. 2.22 ohms, and that is connected with the 2 ohm resistance, and this is the load resistance terminals A and B. So RTH is equals to 2 plus 2.2, which is equals to 4.2 ohms. Now in order to calculate the VTH, Here open circuited, and we need to calculate the open circuit voltage. Here the current is 0, current flowing through 2 ohms is 0. So the VTH is nothing but voltage across the 5 ohm resistance. Voltage across the 5 ohm resistance. So VTH is equals to, what is the current flowing through 5 ohms into that particular resistance value. Here current flowing through 5 ohms is, here it is no current is flowing through the 2 ohm resistance. When the no current is flowing through the 2 ohm resistance, this 20 ohms, 20 volts, 4 ohms and 5 ohms are connected in series. So current I is equals to 20 by 4 plus 5, which is equals to 2.22 amperes. So if it is, here we got the current value as 2.22 amperes. So VTH is equals to 2.22 into 5, which is equals to 11.11 volts. Now we got the VTH and RTH. Now we can replace the circuit with VTH in series with the RTH. Here VTH value is 11.11 volts and RTH value is 4.22 ohms. When we connect with the load resistance 3 ohms, so the current flowing through 3 ohms is I 3 ohms is equals to 1.538 amperes. 1.538 amperes. This is the way we need to calculate the VTH and ITH and current flowing through the load resistance. Now we need to go with another example. Here the load resistance is not given. We need to calculate only the Thevenin equivalent circuit between the AB terminals. That means we need to calculate what is VTH and what is RTH. So in order to calculate VTH and RTH, already the open circuited terminals are given. Already open circuited terminals are given. When the open circuited terminals are given, so we need to calculate the open circuit voltage first, that is nothing but the VTH. So here it is open circuited, so current flowing through 4 ohms is 0. When the current flowing through 4 ohms is 0, so voltage across this 3 ampere source is nothing but the open circuit voltage. But we cannot calculate the voltage across the 3 ampere source because we don't know what is the resistance across the 3 amperes. So this 3 ampere source is connected in parallel to the 20 ohm resistance. So here we are considering that the VOC is equals to voltage across the 20 ohms, that is V2. VAB is equals to V1, that is voltage across the 3 amperes, which is equals to V2. So here we are getting the VAB as V2. So if we calculate the V2, then that is nothing but the VAB value. So here, in order to calculate V2, first we need to calculate what is the current flowing through 20 ohm resistance. For that, let us write the KVL in loop. So by writing KVL in the loop, that is minus 25 plus 5 into I plus 20 into I, which is equals to 0. because here current is entering the negative terminal. So minus 25, and drops will be taken as positive, that is plus 5i plus 25i. So 20i, which is equals to 0, where I is equals to 25 by 25, which is equals to 1 ampere. Now we got the current as 1 ampere, and V2 is equals to current I into 20 ohms according to Ohm's law. V2 is equals to current into that particular resistance, which is equals to current is 1 ampere into 20, which is equals to 20 volts. Now we got, this is our open circuit voltage, that is equals to VAB, which is known as VTH, Thevenin voltage, which is known as Thevenin voltage. Now we need to replace the voltage source with short circuit and current source with open circuit in order to calculate the Thevenin resistance. So here first initially we are having a voltage source. That voltage source is replaced with the short circuit. Voltage source is replaced with the short circuit, and then we are having a current source, and this current source is open circuited, and we need to calculate the equivalent resistance between the AB terminals, that is RTH, that is equals to 4 ohms, 20 ohms, 5 ohms. So here 3 ampere source is replaced with a open circuit. Now we need to calculate the equivalent resistance. If we see between these two terminals, here this 4 ohms, we cannot say whether this 4 ohms is in series with 20 ohms and 5 ohms. So we need to start from the extreme end of the circuit terminals. So extreme end of the terminals are 20 ohms and 5 ohms. So when these are 20 ohms and 5 ohms, these two are connected in here. If you give the current is dividing, and the same current is which is leaving the other terminals of the parallel branches. So then we can say that these two are in parallel. So the R equivalent is equals to 20 into 5 by 20 plus 5, which is equals to 20 into 5, 100 by 25, which is equals to 4 ohms. Now we got the R equivalent between the parallel branches as 4 ohms. Now if we replace the circuit, this is A, B, R, A, B, 4 ohms and 4 ohms. So RAB is equals to RTH. Now we can say that these two elements are connected in series. 4 ohms and 4 ohms are connected in series. When the 4 ohms and 4 ohms are connected in series, R1 plus R2, that is equals to 4 plus 4, which is equals to 8 ohms. Now we got the VTH and RTH. Now we need to replace the circuit with VTH in series with the RTH. VTH in series with the RTH. A, B, 8 ohms, and VTH we got it as 20 volts. VTH we got it as 20 volts. This is the way we have to calculate the Thevenin equivalent between AB terminals, that is voltage source in series with the resistance. So in this session, we have discussed what is Thevenin's theorem and steps to follow the Thevenin's theorem calculation and some examples of Thevenin's theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.